It began with a roar that never should have been heard in the first place, a prototype's engines straining in defiance of physics, shaking the tarmac of a secret airfield somewhere outside Tokyo, while a dozen engineers held their breath and generals watched with crossed arms. The year was 1943, and Japan's empire was burning daylight in the Pacific. American B-17 flying fortresses had been pounding island after island, smashing naval bases and punching holes in supply lines that had once seemed unbreakable. Each mission left Imperial planners more desperate. Every bomb that fell was a reminder. Japan had nothing that could touch the Americans at 30,000 feet. So the order came down from the highest level: build our own fortress. Copy the American giant. Match it gun for gun, engine for engine, and show the world that Japanese ingenuity could rival the industrial thunder of the West. What followed was a story so bold, so riddled with arrogance and tragedy, that it almost sounds like fiction. The saga of the bomber that was supposed to rule the skies but could barely lift itself off the ground. They called it the Nakajima G4M Shinzan, Mountain Recess. To Allied intelligence, it would later be known as Liz. On paper, it looked magnificent. 4 engines, a crew of 10, defensive turrets bristling with machine guns, and a promised range that could carry it from the Japanese mainland all the way to Darwin, even Alaska. The blueprint read like an act of vengeance, a flying fortress forged in Tokyo steel. But blueprints don't win wars. Factories were starving for aluminum, machinists lacked precision tools, and the country's best metallurgists had been diverted to the Navy's Zero program. Still, pride demanded progress, and so a captured Douglas DC-4, a civilian airliner interned in Japan before Pearl Harbor, was stripped, measured, and turned into the skeleton of a dream. Nakajima's engineers studied every rivet, every strut, trying to reverse engineer an American miracle with dwindling resources and constant air raid alerts screaming overhead. Weeks turned to months. The prototype's fuselage took shape inside an assembly hangar wrapped in blackout curtains. Men whispered that the project carried the personal interest of the emperor himself. Failure was not an option, and yet every test uncovered new problems. Imported alloys warped under heat. Engines designed for commercial airliners refused to deliver the power needed to lift a fully armed bomber. Wings buckled, landing gear jammed, and the electrical systems short-circuited with terrifying frequency. Still, no one dared stop. Propaganda posters promised a new super bomber that would strike the American fleet in its harbors, a weapon that would avenge the Doolittle raid and remind the world that Japan still commanded the air. In truth, it was little more than wishful thinking dressed in metal. The morning of the first test flight was cold enough to freeze breath on the canopy. Engineers had been up all night tightening bolts, praying the numbers added up. The pilot, Captain Kawahara, climbed aboard without ceremony, knowing that if this machine failed, the shame would echo through every design bureau in the empire. 4 Nakajima Ha-41 engines coughed, spat smoke, then roared alive. The noise rolled across the field like thunder trapped in a cage. The crowd of officers leaned forward as the bomber inched down the runway, gathering speed, wheels rumbling over uneven concrete. Halfway down the strip, Kawahara eased the yoke back. The nose lifted. For a heartbeat, it looked as if the dream would fly. Then, nothing. The tail scraped the runway, the engines screamed at full throttle, and the massive aircraft simply refused to rise. Spectators gasped as the pilot throttled down, fighting to keep control. The Shinzan came to a shuddering halt with smoke rising from its brakes, its wings trembling like a wounded animal. Silence fell. The bomber that was supposed to rival the B-17 couldn't even take off. That single moment defined the rest of the program. Engineers blamed fuel weight. Generals blamed cowardice. Budgets were slashed, but pride demanded another attempt. For weeks, they tore the machine apart, shaving ounces wherever they could, redesigning the propellers, recalibrating the fuel mixture, anything to squeeze more lift from engines that had already reached their limits. When it finally staggered into the air on its second attempt, barely clearing the trees at the runway's end, the onlookers cheered as though witnessing a miracle. But the victory lasted minutes. One cylinder overheated, another began to lose oil pressure, and the crew could smell burning insulation inside the cockpit. They circled once and landed as fast as they could. Back in the hangar, inspection teams found cracked mounts, warped spars, and hydraulic leaks in 3 systems. The Shinzan was grounded again, this time indefinitely. Inside Nakajima headquarters, morale collapsed. Some engineers quietly admitted what no one dared say aloud. Copying an American bomber was impossible under Japan's industrial strain. The B-17 wasn't just metal. It was the product of thousands of factories, millions of man-hours, and an economy unscarred by blockade. Japan's design teams worked with half-trained laborers and machines that hadn't seen new parts in years. Yet orders from the Army still came. Improve it, lighten it, build more. They tried fitting different engines, Mitsubishi Ha-101s, heavier but marginally stronger. The airframe groaned under the extra mass. Weight reduction meant stripping armor and guns, leaving the bomber defenseless. Every gain on paper meant a loss in survival. The paradox was inescapable. By early 1944, whispers of doom haunted the test fields. The Allies were closing in, the B-29 superfortress was already appearing over the home islands, and the Shinzan still sat grounded, its future reduced to rumor and resignation. A few prototypes managed short demonstration flights, but they were lumbering giants, slower than fighters, easier targets than transport planes. Pilots called it the flying warehouse. Mechanics joked that its most useful role would be as a hangar. Behind closed doors, the project was quietly reclassified as transport development. The dream of a Japanese fortress died without ceremony, buried under paperwork and embarrassment. Still, the myth persisted. In American briefings, Allied intelligence officers speculated about a secret 4-engine bomber hidden deep in Japan's mountains, capable of long-range strikes. Hollywood newsreels hinted at a new menace in the Pacific. The irony was cruel. The legend of Japan's copy turned out far more formidable than the real thing. Inside the crumbling empire, factory workers who had poured years into the Shinzan watched as their creation was dismantled for parts, its wings recycled into scrap for fighter production. Only 2 would ever fly, neither in combat. Both ended their lives burned on the ground, victims not of enemy fire, but of Japan's own unreachable ambitions. And yet the story doesn't end in silence. Because what the Shinzan revealed went beyond its failure to lift off. It exposed the fatal flaw in Japan's wartime dream, the belief that imitation could replace innovation, that pride could outweigh physics. In trying to build a symbol of power, they created a monument to limitation. And as 1945 approached, that lesson would come crashing down harder than any bomb ever dropped from a B-17. The following weeks were a relentless cycle of hope, strain, and crushing disappointment. Engineers worked around the clock, removing weight where they could, recalibrating engines, adjusting wing angles, and tweaking every measurement down to fractions of an inch. The hangar was a hive of activity. Sparks flew as welders reinforced struts, hammers rang against aluminum panels, and draftsmen pored over blueprints, eyes bloodshot from sleepless nights. Each adjustment carried the weight of national pride. Every modification promised a chance at redemption, yet the laws of physics remained immutable, and the Shinzan remained stubbornly unable to rise gracefully from the earth. It was a steel behemoth built for the skies but chained by its own weight and the limitations of an industrial system already stretched thin by years of war. On March mornings, when the air was crisp and frost clung to the edges of the runway, pilots climbed into the cockpit with a mixture of pride and dread. Captain Kawahara, who had become the face of the program, would run through a mental checklist that had grown longer with every failed flight. Engine instruments, throttle response, fuel mixture, propeller pitch, control surfaces, brakes, hydraulics, and the fragile hope that this time the bomber might actually fly. The engines coughed and roared as he taxied forward, wings quivering in anticipation. The hangar crews watched from the sidelines, each man silent, holding his breath, knowing that another failure could crush morale irreparably. As the plane reached takeoff speed, it lifted slightly, trembling, then sank again. Groans and gasps echoed across the field. They had yet again barely survived the first attempt. Even small successes felt monumental. A short hop over the trees or a few seconds of lift were celebrated like victories. But the elation was tempered by the knowledge that operational combat performance required far more than a momentary rise into the sky. Engineers argued endlessly over the details. Would the weight reduction compromise structural integrity? Could the engines handle extended climbs? Would the long-range fuel tanks exacerbate the landing gear failures? Every flight revealed new weaknesses, and every weakness demanded more modifications, creating a vicious cycle that consumed time and resources at a rate the Empire could scarcely sustain. Meanwhile, Japanese intelligence was obsessed with the B-17's effectiveness. Every combat report from the Pacific Theater was studied obsessively: bombing altitudes, defensive armament, engine reliability, and flight endurance. Nakajima engineers tried to replicate these capabilities, yet they lacked the industrial foundation that had allowed Boeing to mass-produce the Flying Fortress with consistent quality. Parts were inconsistent, tolerances were off, and every replacement component required improvisation in the field. Mechanics worked miracles with what little they had, but even the most ingenious solutions could not compensate for fundamental design and production shortcomings. One particularly harsh day in late April, the Shinzan attempted a test flight with minor modifications: lighter armor, slightly adjusted wing flaps, and an experimental engine mixture designed to produce more lift. The aircraft taxied down the runway, engines screaming, shaking violently, and for a moment it seemed as if the machine would finally fulfill its promise. The nose lifted, the tail swung slightly, and Kawahara felt the thrill of flight surge through him. But then, the inevitable happened. The plane's port wing flexed beyond safe limits, a loud metallic groan echoing across the field. Kawahara wrestled with the controls, the engines screaming at full power, and somehow managed to return to the tarmac, battered but intact. Inspectors counted bent struts, cracked panels, and hydraulic fluid leaks, shaking their heads in silent despair. The bomber that had been meant to dominate the skies had revealed its fundamental flaw once again. It was too heavy, too complex, too fragile for the role it was intended to play. Yet orders from the Imperial General Headquarters continued unabated. "Improve it. Make it fly. Deliver results," they insisted. Nakajima engineers continued their desperate tinkering, trying new engine configurations, experimenting with propeller diameters, and rethinking fuel load distribution. Even minor successes came at great cost. Engines overheated, wings flexed dangerously, and every test flight risked losing not just a prototype, but the lives of the men inside. Pilots described the sensation as flying a house tethered to the ground, where each maneuver felt like a gamble against gravity itself. The psychological toll on the test crews was immense. They had gone from pride to frustration, from optimism to grim acceptance of the bomber's limitations. Journals from the era reveal pilots recording mechanical failures, near crashes, and the ever-present fear that the plane could disintegrate mid-air. One engineer noted that while Boeing's B-17s routinely handled flak and enemy fighters, the Shinzan would barely survive a normal test flight. Every attempted improvement highlighted Japan's lack of industrial depth. The impossibility of copying an aircraft born of an economy capable of mass production on an unprecedented scale. In the background, Allied bombers continued their relentless campaign. The B-17s struck deeper into the Pacific and the Philippines, and news of their effectiveness reached Japanese military planners daily. Each report reinforced the impossible task facing Nakajima: to create a machine that could match the Flying Fortress in performance, survivability, and operational endurance, with resources and materials that were dwindling as the war turned against Japan. It was a race against time. But the gap between aspiration and reality grew wider with each failed flight. Despite repeated setbacks, the engineers found a strange persistence in their work. Every failure prompted new calculations, revised schematics, and incremental improvements. They replaced engines, rebalanced the airframe, and recalculated lift-to-weight ratios with painstaking precision. Every adjustment came with risk, and every test flight carried the specter of disaster. Yet hope persisted, a fragile thread binding men to the impossible task of creating a Japanese B-17 clone, the First successful short hop occurred in early May, a flight that barely cleared the treetops and landed with heavy vibrations, and sparks flying from the landing gear. While it did not resemble the graceful performance of the American original, it was a moment of triumph for the crews and engineers who had labored for months. The press, tightly controlled by military authorities, described it as a promising demonstration of Japan's aerial engineering prowess, though the language masked the deep deficiencies that remained. Onlookers cheered cautiously, aware that what flew for a few seconds on a test field might never survive a combat sortie. By June, incremental improvements allowed slightly longer flights, but the aircraft remained unpredictable. Weight distribution was still a major problem, causing pitch instability. Engines overheated under continuous full-throttle operation, and fuel consumption was far higher than projected. The bomber could barely carry a fraction of the armament intended, and defensive capabilities were minimal compared to the B-17. Test pilots reported severe vibration in the fuselage, difficulty maintaining altitude, and the constant fear that structural failure could occur at any moment. Yet Nakajima persisted. Engineers innovated with what little material they had, trying composite solutions, reinforcing wing spars, and experimenting with aluminum alloys salvaged from other programs. Each small advance was celebrated internally as if it were a victory, though in reality the Shinzan remained unable to fulfill its intended role. It could fly, but combat performance was still a distant dream. The disparity between ambition and reality had never been more apparent. Japan had sought to replicate the pinnacle of American engineering, only to discover that imitation could not substitute for industrial capacity and experience. The pilots continued their grueling flights, pushing the aircraft to the limits of its fragile airframe. They discovered that crosswinds could cause catastrophic instability, that takeoffs required longer runways than initially calculated, and that landing with a full fuel load was nearly impossible without risking collapse of the landing gear. Injuries were narrowly avoided in several incidents, reinforcing the growing reputation of the Shinzan as a machine that demanded respect even when it could not fight. As summer approached, the Nakajima program quietly shifted focus. Recognizing the bomber's inherent limitations, planners began to divert resources to lighter twin-engine designs and to modifications for transport roles. The Shinzan, once intended as Japan's answer to the B-17, was relegated to a symbol of overambition, a flying project that embodied both the hope and the hubris of an empire struggling against overwhelming odds. Yet the legend of its design, the secrecy surrounding the prototypes, and the dramatic failure to lift off in its early flights gave it a strange immortality, whispered about in engineering circles and later chronicled by Allied intelligence as the bomber that could not fly. By late June, the test program had entered its most desperate phase. Engineers had exhausted every feasible adjustment to engines, propellers, and weight distribution. Each flight was a high-stakes gamble against gravity, material failure, and human endurance. Captain Kawahara and his co-pilots were no longer simply testing an aircraft. They were testing the limits of Japanese engineering under extreme pressure. The sun rose over the Tokyo outskirts, a pale orange disk illuminating the concrete of the airfield as the Shinzan lumbered toward takeoff. Its massive wings flexed like trembling arms, engines screaming in protest. Ground crews held their breath, knowing that another catastrophic failure could erase months of labor, perhaps even claim the lives of the test crew. The bomber struggled down the runway, its tires leaving streaks of black on the concrete, the roar of the four engines reverberating across the field. For a fleeting moment, it lifted slightly, the nose rising as if in triumph. Then the inevitable occurred. A violent shudder ran along the fuselage, landing gear straining under the impossible weight, and the aircraft dipped dangerously before Kawahara regained control. The Shinzan skidded to a stop, metal squealing against the tarmac. Crews ran forward to inspect the wings, only to find new cracks along the spars, twisted mounts, and engine mounts scorched from overexertion. What should have been a routine test flight had become another demonstration of the bomber's tragic limitations. Engineers debated furiously over the next steps. Should they reduce fuel load even further to save weight? Could they strip more armor, sacrificing defensive capability for minimal lift? Would a complete redesign of the landing gear allow the bomber to even reach altitude safely? Each proposal came with inherent risks: flight instability, structural failure, or even total loss of the prototype. Despite the growing impossibility of success, the Imperial Army's orders were absolute: make it fly, make it carry bombs, and make it rival the American B-17. Pride, honor, and the escalating demands of war drove the team to attempt solutions that were increasingly desperate. The following days saw the introduction of new engine configurations. The He 109s, previously considered insufficient, were overhauled with experimental supercharging techniques intended to maximize lift at altitude. Mechanics worked feverishly, testing fuel mixtures, lubricants, and propeller adjustments in the hopes of extracting marginal gains. The Shinzan, however, remained fundamentally overburdened. Each flight revealed new instabilities. Rudder response was sluggish, elevators had delayed reaction, and the massive fuselage flexed alarmingly under stress. Pilots reported vibrations that rattled instruments loose, engines that surged, then sputtered, and an unshakable feeling that at any moment the aircraft could disintegrate in mid-air. By mid-July, the bomber achieved its longest flight yet, a harrowing journey barely 30 miles from the airfield. The engines were at full throttle, cylinders overheating, and fuel tanks dangerously close to empty. Kawahara's crew executed emergency adjustments mid-flight, redistributing weight and manually adjusting throttle balance to maintain altitude. The landing was perilous, requiring expert timing and nerve, yet they succeeded. For a moment, the hangar crews cheered. For an even briefer moment, hope surged that the Shinzan could eventually be made airworthy. But the cheers died quickly when engineers examined the aircraft and found more structural damage than before. Warped spars, cracked rivets, and wing mounts stretched nearly to their limits. Each flight's success merely highlighted the aircraft's inability to survive operational conditions. The psychological toll on the team became evident. Test pilots recorded daily logs filled with tension, frustration, and a growing awareness of the impossible task before them. Mechanics and engineers worked tirelessly, often through nights illuminated by floodlights and electric lamps, repairing, modifying, and tweaking components that were never intended to support the stresses of the Shinzan's weight. Rumors circulated among the crews that the bomber would never see combat, that its only use might be as a training aircraft or a static target for gunnery practice. Yet the orders from Tokyo remained unchanged: build it, improve it, make it fly. The clash between ambition and reality became a quiet torment, a reminder that in war, engineering genius alone cannot overcome the limits of resources, materials, and physics. By August, the situation had grown critical. Allied intelligence was already cataloging Japan's bomber limitations, and the pressure to produce an operational heavy bomber mounted with each American raid. Nakajima engineers were forced to adopt extreme measures, reducing fuselage weight by removing internal bulkheads, substituting lighter yet weaker alloys, and experimenting with alternative engine mountings. Each modification made the Shinzan more fragile and unpredictable. Test pilots described the aircraft as a house with wings, warning each other that a hard bank or sudden climb could result in catastrophic failure. Yet, in defiance of both logic and physics, flights continued, sometimes lasting only a few minutes before the bomber returned, trembling and damaged. The final attempts in late August were marked by extraordinary desperation. Kawahara and his co-pilots conducted flights with minimal fuel, stripped of nearly all defensive equipment, and with engines pushed beyond recommended tolerances. Each takeoff was an ordeal. The aircraft's massive weight caused the nose to lift only briefly before it settled dangerously, wings flexing under tension, the tail bouncing across the runway in protest. Yet somehow, through expert piloting, the bomber managed brief hops into the air, moments that engineers celebrated as tentative victories. Still, each landing revealed new fractures, additional wear, and the undeniable truth: the Shinzan, despite every effort, could never match the American B-17 in lift, speed, durability, or operational readiness. As September arrived, the Nakajima program quietly shifted objectives. Rather than attempt true combat operations, the bomber was relegated to experimental flights, engine testing, and occasional transport duties. Its legacy, while technically a failure, became a cautionary tale of ambition overreach, a symbol of what can occur when imagination outruns industrial capability. Only a few prototypes survived, grounded permanently, while the war continued with the Japanese military forced to rely on lighter bombers, fighters, and kamikaze tactics. Yet the story of the Shinzan lived on. In American intelligence reports, in whispered legends among engineers and in post-war analyses, it was remembered not for its success, but for the audacity of its conception, the drama of its repeated failures, and the lesson it imparted. Copying a technological marvel without the infrastructure, resources, or industrial depth that created it is a recipe for disappointment, no matter how brilliant the minds behind it. The bomber that was meant to rule the skies had never even conquered the runway. By late September, the Nakajima team had exhausted nearly every conceivable adjustment to the Shinzan. The bomber that had once promised to dominate the skies now occupied a precarious space between legend and humiliation. Engineers had replaced engines multiple times, experimented with radically altered propellers, reworked wing spars, and stripped fuselage components to lighten the weight. Every modification produced minor improvements, but the aircraft's fundamental flaws remained. It was too heavy, too unstable, and far too fragile to survive operational combat. Pilots approached each flight with a mixture of dread and grim determination, knowing that even the smallest miscalculation could end in disaster. Yet they persisted, driven by duty, pride, and the weight of expectations from military authorities in Tokyo. The first flights of this phase were meant to test the bomber's endurance under minimal fuel load and stripped defensive armament. Captain Kawahara climbed into the cockpit, joined by his co-pilot and a skeleton crew of mechanics, while ground engineers monitored the engine's performance, fuel pressure, and hydraulic systems. As the Shinzan taxied toward the runway, the combined roar of 4 overworked engines filled the air like an approaching storm. The bomber lurched forward, struggling under its own mass, tires squealing against the concrete. For a brief moment, the nose lifted gracefully, and Kawahara allowed himself a fleeting hope that the aircraft might finally sustain level flight. That hope was short-lived. The engines struggled to maintain thrust, vibrations rattled the fuselage, and the tail began to sag dangerously. Kawahara wrestled with the controls, barely keeping the bomber on a straight course. Ground crews watched helplessly as the aircraft trembled and groaned under its own weight. For a tense minute, the Shinzan teetered between lift and collapse before Kawahara managed a tentative landing. Sparks flew from the landing gear as it skidded across the tarmac, metal screeching and rivets popping from stress. Inspectors rushed forward to assess damage. The wings had developed new stress fractures, engine mounts were compromised, and several control cables were frayed. Despite the apparent success of the flight, it was evident to all that the bomber was dangerously close to structural failure. In the hangar, engineers debated their next steps. Some proposed a complete redesign of the wing structure, incorporating additional spars and braces to support the enormous weight. Others suggested replacing engines with newer, more powerful variants, despite shortages of critical components. Every option carried trade-offs. Adding reinforcements increased weight, new engines strained production capacity, and time was running out as Allied bombing campaigns intensified. The Shinzan, once a symbol of ambition, had become a case study in the limits of replication and resource scarcity. Despite the setbacks, the team continued its efforts. Test flights were scheduled with increasing frequency, each attempt pushing the limits of both the aircraft and its crew. Pilots reported severe oscillations during takeoff and landing, unstable pitch control, and engines that overheated within minutes of sustained flight. Mechanics improvised solutions, reinforcing panels with salvaged alloys, modifying control surfaces, and recalibrating fuel mixtures. But every success revealed another flaw elsewhere. The bomber's design was fundamentally incompatible with Japan's wartime industrial capabilities, and yet the program pressed on under relentless pressure from military authorities. One particularly harrowing flight occurred in early October. The Shinzan, equipped with experimental engines and stripped to minimal operational weight, attempted to sustain level flight at 5,000 feet. Kawahara reported extreme vibration through the control stick, unusual yaw, and engine surges that threatened to stall the aircraft. The bomber managed to maintain altitude for only a few minutes before fuel pressure dropped unexpectedly, forcing an emergency landing. Ground crews rushed to secure the aircraft, discovering cracked wing spars, warped fuselage panels, and burned insulation around the engine compartments. The bomber had survived, but only barely, and each successive flight seemed to push it closer to complete structural collapse. The psychological impact on the team was profound. Engineers grew tense, mechanics exhausted, and pilots increasingly wary of flying a machine that could fail at any moment. Journals from the period describe a growing sense of despair, a recognition that no amount of ingenuity could overcome the fundamental limitations of the Shinzan's design and the scarcity of materials. Yet the order remained clear: make it fly, make it operational, and deliver results. Pride, duty, and the rigid hierarchy of military command drove the team to continue despite overwhelming evidence that the project could never achieve its original goals. By November, the Nakajima program had shifted its focus toward secondary roles. Recognizing the bomber's inability to carry out sustained combat missions, planners explored using the Shinzan for transport, reconnaissance, or experimental testing. Even in these reduced roles, the aircraft's structural weaknesses persisted. The fuselage flexed dangerously under load, engines required constant maintenance, and flight times were limited by fuel inefficiency. The bomber's story, once one of ambition and secrecy, had become a narrative of limitation and compromise. Yet the Shinzan's legacy persisted. Within Japan, it was quietly acknowledged as a remarkable technical achievement in the face of impossible odds. Among Allied analysts, the aircraft became a symbol of Japan's industrial and logistical constraints, a cautionary tale of what occurs when ambition outpaces capacity. The bomber's repeated failures, catastrophic test flights, and inability to leave the runway as intended became legendary, discussed in engineering circles and post-war analyses as evidence that replication without the supporting infrastructure is doomed to failure. Even in its final days, the Shinzan inspired both fear and fascination. Engineers, pilots, and historians would later describe the bomber as a marvel of design ambition, a machine that had attempted to challenge the industrial might of the United States, but ultimately could not overcome the limits imposed by material scarcity, wartime pressures, and structural physics. Though it never achieved operational combat status, the Shinzan remained an enduring symbol of audacity, a testament to the human desire to conquer the impossible, and a lesson in the unforgiving realities of war. And so, the first point of this story concludes with a bitter irony. The plane meant to dominate the skies became a reminder of the limits of replication, the consequences of overambition, and the price of underestimating both physics and industrial capability. Japan's B-17 clone, for all its promise, had failed to leave the runway. Yet its tale would echo through history, a dramatic and cautionary legend for generations of engineers, pilots, and strategists alike. As autumn settled over Japan, the Shinzan program entered its final, most desperate phase. The bomber had survived dozens of test flights, each one pushing the limits of its fragile frame, and every sortie exposed new structural flaws, engine failures, or instability in the air. Captain Kawahara and his co-pilots had become intimately familiar with the machine's quirks, the way it shuddered under stress, the tendency for the tail to sag during takeoff, the unpredictable response of control surfaces at higher altitudes. Each flight was a gamble. Each landing was a battle against gravity, weight, and human endurance. Yet the orders from Tokyo remained absolute: produce a heavy bomber capable of rivaling the B-17, and do so immediately. Engineers worked tirelessly, often late into the night under dim floodlights, welding, recalibrating, and replacing components in a near-continuous cycle of repair and modification. Aluminum panels were hammered and reshaped, engine mounts reinforced with whatever alloys could be scrounged from other programs, and landing gear re-engineered to withstand the stress of repeated takeoffs and landings. Every minor success revealed additional weaknesses: a wing spar that flexed dangerously under load, a control cable fraying under vibration, or engines overheating after only a few minutes at full throttle. The Shinzan was a machine perpetually on the edge, a fragile giant held together by skill, ingenuity, and desperation. One fateful test flight in mid-October epitomized the bomber's tragic contradictions. The Shinzan, stripped of excess weight and fitted with modified engines, rolled down the runway at full throttle. The massive fuselage flexed, wings trembling as if alive, and Kawahara guided the aircraft into the air. For a brief moment, the bomber seemed to defy its critics, lifting gracefully above the trees. Ground crews erupted in cautious applause. But the victory was fleeting. Within moments, the engines began to surge uncontrollably, vibrations tore loose panels, and the rudder reacted sluggishly. Kawahara fought to maintain control, executing emergency maneuvers that tested both his skill and nerves to the limit. The landing, when it came, was perilous. Sparks flew from the landing gear, metal groaned under the weight, and the aircraft shuddered violently before finally coming to a halt. Inspectors rushed forward to assess the damage, discovering new fractures in the wings, warped fuselage panels, and burnt insulation around engine compartments. It was a miracle the crew had survived, yet another reminder of the bomber's inherent instability. Behind the scenes, bureaucratic pressure mounted. High-ranking officials demanded progress reports, promised accolades for successful flights, and warned of consequences for failure. Engineers, already exhausted from months of continuous labor, faced the impossible task of demonstrating operational capability with an aircraft that fundamentally could not meet expectations. Meetings were tense, with planners arguing over engine choices, fuel loads, and structural reinforcements, each discussion highlighting the unbridgeable gap between ambition and reality. Some engineers quietly suggested abandoning the project, but the strict hierarchy of military command, combined with the stigma of failure, made such suggestions politically dangerous. Pride, duty, and fear drove the team forward. Even as the Shinzan's failures became increasingly public among insiders, the bomber's final experimental flights were a testament to both human determination and technological hubris. Pilots conducted short sorties under minimal fuel load, stripped defensive armament, and carefully calculated weight reductions. Each flight required expert skill to maintain control, manage engine performance, and safely return to the runway. Observers noted the immense stress placed on every component: wings that flexed under minor turbulence, landing gear that screamed under braking, and engines that pushed beyond recommended limits to generate enough lift. Every landing revealed new structural weaknesses, yet each flight also provided invaluable data, feeding back into a cycle of incremental improvements that ultimately could never overcome the aircraft's fundamental deficiencies. By November, it became clear that the Shinzan could never operate as an effective combat bomber. Its maximum altitude was too low to evade enemy fighters, its range insufficient for strategic missions, and its defensive capabilities minimal compared to the B-17, the aircraft that had once been envisioned as Japan's weapon to challenge Allied air power had instead become a symbol of overambition and limitation. Engineers documented its flaws meticulously, pilots recounted harrowing flight experiences, and planners reluctantly redirected the few remaining prototypes to transport and experimental roles. Though they could fly, these versions were little more than test beds, incapable of performing the missions originally intended. Even in failure, the Shinzan left a lasting impression. Its story was recorded in engineering reports, intelligence briefings, and post-war analyses as a cautionary tale of what occurs when ambition exceeds industrial capability. Allied intelligence, unaware of the full extent of Japanese engineering efforts, sometimes overestimated the aircraft's capabilities, mistaking its massive frame and secretive test flights for a potential threat on par with the B-17. In reality, Japan's attempt to copy the Flying Fortress had revealed a critical truth. Replication without the underlying industrial depth and material resources of the original creator is doomed to failure. The final flights, though brief and largely unsuccessful, served to highlight both the ingenuity and desperation of the Nakajima teams. Engineers worked miracles with limited resources, pilots demonstrated extraordinary skill to keep the aircraft airborne, and test crews endured extreme danger with little recognition. The Shinzan, for all its flaws, embodied the human drive to achieve the impossible, even in the face of overwhelming obstacles. Its failure was as much a testament to the limits of wartime Japan as it was to the audacity of its designers and crews. As the program wound down in late 1944, the remaining prototypes were retired, stored in hangars or dismantled for parts. The legacy of the Shinzan lived on in whispered stories among engineers and pilots, a blend of awe and frustration at what might have been. It became a symbol of Japan's attempt to match American industrial might, a dramatic narrative of ambition, desperation, and the unforgiving realities of war. The bomber that had been intended to dominate the skies instead became a cautionary legend, a flying testament to both human ingenuity and the stark limitations imposed by circumstance, material scarcity, and the laws of physics. The Shinzan's final flights in December marked the last chapter of its troubled existence. By now, the bomber had become more a symbol than a weapon, a cautionary tale whispered in engineering offices, hangars, and intelligence briefings. Captain Kawahara and his crew, hardened by months of impossible flights, prepared for what was officially labeled evaluation sorties, though in reality these flights were more about gathering data than testing combat readiness. The airfield was quiet in the early morning, mist rolling over the tarmac, engines idle as the massive aircraft awaited its final takeoff. The tension among engineers and ground crews was palpable, each man acutely aware that this machine had never truly flown as intended, that every success had been fleeting, and that the bomber's fragile structure could fail without warning. As the engines roared to life, shaking the hangar and sending plumes of smoke into the cold air, Kawahara gripped the controls with a mixture of anticipation and grim resolve. This flight would push the Shinzan to its operational extremes: maximum lift, highest sustained altitude, and extended duration under controlled conditions. The engines coughed and screamed as the bomber lumbered down the runway, wings flexing under their own immense weight. For a fleeting moment it rose above the tarmac, a massive silhouette against the pale winter sky, a monument to human ambition daring to defy physics. Yet even in this moment of awe, the cracks in its armor were visible, literally and metaphorically, as rivets popped, fuselage panels vibrated, and hydraulic systems groaned under strain. The crew pressed on, navigating carefully to maintain altitude while monitoring every instrument. Oil pressures fluctuated, engines surged, and the control surfaces responded sluggishly to Kawahara's precise inputs. The flight, intended to showcase the bomber's capabilities, instead highlighted its fundamental flaws. Yet, in the drama of the moment, there was a strange beauty. The Shinzan, despite all its limitations, was airborne, a fleeting triumph over the constraints that had bound it to the runway for so long. The crew experienced both exhilaration and dread. The thin line between survival and catastrophe was visible in every shudder, every groan of stressed metal. As the flight drew to a close, the bomber's descent began. Kawahara guided the aircraft with meticulous care, aligning it with the runway, compensating for tail sag, and modulating engine power to prevent collapse upon touchdown. The landing was rough but successful, a testament to pilot skill rather than the aircraft's engineering. Ground crews rushed forward, inspecting the bomber for new damage. Cracks had widened, engine mounts were scorched, and control cables frayed further. Yet the Shinzan remained intact, a battered but resilient giant. Engineers took meticulous notes, recording the stresses and failures, knowing this would be the final chapter in the bomber's operational history. In the aftermath, the program was officially concluded. The Shinzan would never see combat. Its engines, wings, and fuselage would be repurposed, and the remaining prototypes quietly retired. Yet the story of the bomber did not end there. Among engineers, pilots, and military historians, the aircraft became a legend, not for its destructive power, but for its ambition, perseverance, and tragic flaws. It symbolized both the ingenuity and overreach of wartime Japan, a monument to the limits of imitation and the cost of attempting to replicate a technological marvel without the necessary industrial foundation. The Shinzan's final legacy was cemented in its lessons. Copying a technological marvel is never enough. Ambition must be tempered by reality, and no amount of ingenuity can overcome the immutable laws of physics and resource scarcity. Allied intelligence, initially mystified by the rumors of Japan's heavy bomber, eventually pieced together the truth. The aircraft was incapable of operational flight. In that revelation, the Shinzan story became both a historical footnote and a cautionary tale for generations of engineers and strategists. And yet, in that final bitter irony, there was drama worthy of the cinematic eye. The bomber that had been intended to dominate the skies became an enduring symbol of human ambition. A machine that almost flew, almost challenged the great B-17, but ultimately could not conquer gravity or its own flawed design. Pilots who had flown it remembered the tension, the terror, and the fleeting beauty of controlling something that teetered constantly between triumph and disaster. Engineers remembered the countless nights, the sparks, the groaning metal, and the stubborn will to achieve the impossible. The story closes with a chilling reminder. In war, the limits of technology, material, and industrial capacity are unforgiving. The Shinzan never dropped bombs, never turned the tide of battle, yet its legend lives on, a testament to audacity, persistence, and the high price of ambition unchecked by reality. As the final hangar doors closed and the last engine cooled, the bomber lay in silence, a steel monument to dreams that almost touched the skies, leaving behind a legacy as dramatic, suspenseful, and haunting as any combat mission could ever be. Japan had tried to replicate America's ultimate bomber, to defy the laws of physics, to assert dominance in the Pacific, yet all that remained was the echo of roaring engines on a frozen tarmac, the memory of men daring to fly a dream that would never truly leave the runway.